I did not. Okay, now I am recording. I am recording now. Sorry, thank you for reminding. Right. Okay. So if you say record equal to, what did I type? Windows in brackets records equal to true. That means it will record everything that you're doing. Now, if you say device new, open bracket, close bracket, that means you're opening a device. You're opening a device. That's what it means, right? So every device has a number. So in this case, the device number is 2, right? Okay. Now, if you want to set something like, if you want, like suppose I think so. It is. I think it's the same in Mac. I think, Melody, you may want to check that out. I think it's the same in Mac. Yes. Right. So every device number has a number. So in this case, the device number is number 2, right? Okay. Now, if you say device set 2, it will set the device that you're going to use to be 2. But sometimes you can have more than one device. So in this case, you have only one device open right now. Okay. Now, if you want to switch off the device, you say device off in brackets 2. So you will see the device has disappeared, right? Okay. Okay. So that's the way how. So and especially when you have multiple windows, you can choose which window you want to choose to plot something, right? But in the example that I just did, I only had one window. Right, now the next thing I'm going to show you is how to do plotting. Now suppose, let me create an object called Paul. I think I did this in the last tutorial. Conservative. So it's a Paul is an object containing the names of the 4 parties: Conservative, Labor, Liberal Democrats, UKIP, and other, right? Okay, these are the 5 parties. I'm gonna repeat them. I'm gonna repeat them. Okay, I want to repeat Conservative 369 times, Labor 314 times, Liberal Democrats 75, UKIP 118, and other 124. So this is what I will get. So if you want to type, this is what you will get, right? Okay. Now I'm gonna convert Paul into a factor variable. So let me call this Paul F, right? Now if you type table Paul F, this is a summary of the data, right, that you have. Now if you say plot, excuse me, plot, this is what you will get, you see. So you get this plot. What this plot shows is the number of votes that each party got, or number of seats each party got. Conservative, Labor, Liberal, Democrats, other, and UKIP, right? Okay. So this, I mean, so when you have like a categorical data, like bar plot, this is known as a bar plot. Bar plot is something very useful to represent categorical data, right? Okay, the next thing I'm gonna do, I'm gonna show you is, remember this data. This is the time data that we talked about before. Now, suppose you want to do like a histogram of this. This is what you will get. So this is the histogram of the time data, right? Now, here, if you look at this histogram, the y-axis has the frequency. The x-axis is the interval, right? Now, suppose you want to do a density plot. Instead of frequency, you want the y-axis to be density. Then You see, now the y-axis is density, right? Not frequency. So to do that, you just have to say frequency equal to false. Okay, F for false, okay? And you can also control how many breaks you want on the x-axis. So 14 is the number of intervals that you have on the x-axis, right? Okay, and you can also control, like, instead of saying 14, you can actually specify the intervals that you want on the x-axis. So for example, if you want the intervals to go from 47 to 51 in steps of 0.4, you can say this, and excuse me, what I have done. Sequence from I think I left out something here, from to by. What did I do? To by sequence. Should be 51. Yeah, excuse me. Yeah, it should be 51. Thank you. Thank you, Christian. Sorry, I'm being stupid today. I don't know. So it should be 51. You see, so the breaks are from 47 to 51 in steps of 0.4. So you see the breaks are going from 47 to 51, and each interval is of length 0.4, right? And you can also change. I mean, you can change it as whatever you want it to be. So you can, for example, change this to 46.8, change this to 50.8, and this is what you will get, right? Okay. So histogram is a very useful tool for just plotting numerical data, right? All right, the next thing I'm going to talk about is box plot. Remember box plot, I talked about it about a week or two ago. Now let's consider the time data again. So if you type box plot of t, this is what you will get. All right, here, the middle line is the median. This line here is the first quartile. This is the third quartile. This is the lower adjacent, and this is the upper adjacent, right? The lower fence and the upper fence are beyond the range of the plot, right? Okay, and I showed you how to compute the lower adjacent and the upper adjacent in the tutorial. I think we did last week or something. Yeah. Okay. Right. Okay. So that's the next thing I'm going to do is to go back to the course website and read the runners data set. This is a data set containing like the concentration of a chemical and whether the runner was successful or not successful, meaning collapsed. So let me copy the URL, copy, and go to the course website. So let me read table. This is, as I said before several times, this is the command that you need to use. And let me call this data runners. Okay. And once again, the header for the data set is true, right? So now if you type runners, you see there are two columns of data. The first column is the concentration of a chemical, and the second column is is whether the runner collapsed or not, right? So if you type names, you see there are two columns, PMOL and group, right? Right. Now, let me show you what we can do with this data. Now, if you want to do a box plot of the PMOL is the, well, you can do it like this. I mean, one way to do it is to check runners at PMOL, so $PMOL, right? So PMOL, then tilde, runners, dollar group. And this is what you will get. You see, this is the box plot that you will get. So what we have plotted here is the box plot of the concentration for two groups. The first group is the group that did not complete the run, did not complete the running. The second group is the box plot for the concentration for the runners who did complete, right? So you can see that the distributions are different. The concentration for the runners who did not complete is higher than the runners who did complete, right? Okay, and also the variability is higher for the people who did not complete, right? Remember the width of the box shows how variable the data are. The variability here is a lot smaller, right? Compared to this, right? Right. Now you can, instead of another thing you can do is to look at the runners that corresponds to high concentration, right? So we are looking for all the runners who have a concentration exceeding 100, right? So that's how you. So, excuse me, what did I do again? Oh, sorry, I think I meant to write $, not this. Okay, so here high concentration picks all the runners, right, that have a high concentration of P-mol, right? Then you should type runners high, okay? And look for the subset of runners with the subset corresponding to high concentration, okay? And then you should type this. This is what you will get. See, it's a subset of the data set where the concentration is greater than 100, okay? It's a subset of the data set with concentration exceeding 100. So it starts from 102 up to 414. Now, if you summarize, you should do a summary of this group, right? Okay, this is what you will get, right? This is what you will get. There are 7 people. There are 7 people in this subset, and all of them correspond to collapsed, and the 0 of them correspond to successful. So you can actually drop this level because there's no one who was successful. So you can drop this level. Now, one way to drop the level is to use the command drop level. So if you say drop levels, right? And then do a summary. Then you do a summary of the data after dropping the levels. You will get only. So you will get only the collapsed, right? Only the collapsed, and not the successful, because none of the, in this group, all of them collapsed. None of them were successful. So after dropping the level, you see that you get only those who collapsed, because none of them were successful, right? Okay. All right, now that's the next thing I'm going to show you is how to do scatter plots. Now, suppose X are the integers from 0 to 5, right? So these are the numbers. Now, suppose you want to plot X versus y. And this is what you will get, right? This is the plot of x versus y. Now, this is not a very good plot. Now let me do this one more time. Suppose, excuse me, suppose you define x to be all the numbers from -5 to +5. Then if you do the plot one more time, this is what you will get, right? So you see that this is like a parabola. I'm sure you've seen this shape before in your first year and maybe also in your A-level, right? Now you can actually do like a issues type equal to L. L stands for line. This is what you get. L, by the way, this is not 1, this is L, right? So some people got confused this with 1. Not, it is not 1. L stands for line. So I should say, excuse me, L denotes line, okay, not 1, right? And you can also change the colors, like, okay, suppose X is a sequence from 0 to 5 with the length of 100, all right? Then you have this sequence, right? And now suppose you want to plot X versus X squared with type equal to L and color equal to 2. This is what you will get, right? And you can change different numbers for color produced, like color equal to 3 is green, right? Color equal to 4 is blue, and so on, right? Okay, now you can also do like a lines command, like a lines X versus X cubed, right? With say color equal to 4 will produce this. So what you see here is a cubic. So this one is a cubic and this one is a quadratic, right? Okay, they're both on the same graph. All right, so that completes the tutorial. But now I've got 3 exercises to do, starting with exercise 1. I think we have time. Exercise 1. Did you guys looked at this exercise or not? Hello, guys. Did you look at exercise 1? Now, what you need to do is the following, guys, right? Let me show you. It's not difficult. So you go to the course website, which is this one, right? And go to the simulated data set, right? So copy this data set, copy, and go back to R, paste, right? Excuse me, did I paste? No, paste, okay. Then let me call this sim data, right? Then read dot table, open quote, end quote, header equal to true. All right, now if you type sim dat, you see the data that I just read, right? It has 2 columns. If you say names equal to sim dat, it has 2 columns, case and X, right? Now the column that we are looking for is the second column, right? Which is sim dat $X, right? This is the column that we are looking for, right? And the question is to find the summary statistics. So for example, if you type 5-number summary, say 5 numbers of XS, right? So this is the minimum, the first one is the minimum, the second is the first quartile, the median, the third quartile, and the maximum. So if you say this is equal to say F and S, your interquartile range is the difference between the third quartile and the first quartile. So this is the interquartile range. You can also do like use the summary command. The summary command will return this. So this is the minimum, the first quartile, median, mean, third quartile, and the maximum, right? And you can use the command var to compute the variance or the sample variance. And you can use the command sd to compute the sample standard deviation. And you can do a box plot using the box plot command. So you see, this is the box plot of the data. It kind of shows that it's slightly skewed, but generally is slightly skewed because the median line is not halfway between the first quartile and the third quartile. I mean, if the distribution is symmetric, you would expect the median line to be halfway, but it's not. But it's kind of shifted. So it's only slightly skewed, right? Okay. All right. The next thing we need to do is that all? Sorry. And okay, we are also asked to do a histogram, right? So to do a histogram of the data, you just type the command hist, H-I-S-T, XS. So that will do the histogram. Now you have frequency as the y-axis. Now, if you want to change that to density, you say frequency equal to F. So you see now this is density on the y-axis. You can change the x-axis using the breaks command. So suppose you say breaks equal to sequence from 6 to 16.5 in steps of 1.5, right? This is what you will get, right? So the x-axis goes from 6 to 16.5 in steps of 1.5. If you want it to be, say, 6.25 to 15.25 in steps of 1, this is what you will get. So now the x-axis goes from 6.25 to 15.25 in steps of 1, right? Okay. It kind of looks symmetric. I mean, once again, sorry, it kind of looks skewed, right? It's not exactly symmetric, but it's kind of skewed, right? All right, so that's what you see. All right, that's exercise 1. Exercise 2, by the way, any questions on this exercise? Yes, you can save the histogram. Yeah, to save the histogram, what you need to do is you click on this window, right? And then you go into File, then you say Save As. Okay, click Save As, and you can save as one of these types, either as PostScript, PDF, PNG, bitmap, TIFF, or JPEG. So there are you have to choose one of these options and then save, right? I'm not going to save, but if you want, you can save it as one of these options, right? Okay, sir. All right. Right. Now let's go to question 2, exercise 2. Any other questions on? Well, any other questions on exercise 1? Guys, sorry, I didn't ask you. If you have, do you guys have other questions on exercise 1 before I go to exercise 2? Talk to me, guys. Are you okay now? Okay, thank you, guys. Let's go to exercise 2 then. Exercise 2 is to read the data from a Giza in the Yellowstone National Park in the United States, right? So you go to the Giza data, which is, let's go here. This is the Giza data set. So it has 3 columns, the day, the duration, and the interval, right? So let me copy this, paste, right? Paste this. So I'm going to read it. I'm going to call this data Geyser, G-E-Y-S-E-R, read dot table in quotes left quad, right quad, header equal to true. All right. Now, if you type names in Giza, it has 3 names corresponding to the 3 columns. The first column is day, the second column is duration, the third column is interval. Right. Now, we are interested in the duration, the second column. So let's call that XT. So XT is going to be Giza dollar duration. So this is the data that we're interested in. So let's do a summary statistic. So summary of XT. So it gives you the minimum duration, the first quartile, the median, the mean, the third quartile, and the maximum duration. VAR produces the variance. ST produces the standard deviation. Now, you should do a box plot. Sorry, let's put on a box plot of XT. This is, you see, this is what you get. This is very skewed. As you can see, it is very skewed. It's not even close to being a normal distribution, right? It's highly skewed, right? Okay. Now, let's see. Sometimes the box plot is not so informative. Sometimes it's better to do like a histogram than a box plot. First line of the data set will be as the header names. Yeah, you're right. Yeah, Christian. I mean, the first line, when you type names in brackets, the name of the data set, it tells you the names of the column. It gives you the column names, in the data set, right? So the column names are day, duration, and interval, right? Okay, that's why when you read the data, it's always a good idea to say header equal to true. So it picks out the column names, all right? All right, now, what was I saying? Sometimes it's better to do a histogram than a box plot. The reason for that, I will explain in a minute. Now, you see, this is a histogram with frequency. Now, we want frequency to be false, all right? So let's repeat that with frequency equal to false. And let's say take breaks to be 16, right? So you see, this is what you see. And the reason for this is because in this Yellowstone National Park, there are some geysers that are short burst, that they burst only for a short amount of time. And that corresponds to the first mode, right? And you see, there are 2 modes in this histogram. There's a mode around this, and there's a mode around this. So the mode around this corresponds to short duration bursts, short duration. And the mode around this corresponds to long duration modes. So what you have is a mixture of 2 different distributions. Okay, mixture of 2 different distributions. That's why you get this bimodal shape. Okay, bimodal shape. Okay, right. All right, so you can change the breaks to as you want. Like, for example, you can take the breaks to be, say, from 1.5 to 5.5 in steps of 0.25, all right? This is what you get, right? And you can also take it from, say, 0. Like this. This is what you get. And you can also take it to like this. This is what you get. And in all cases, you see that, excuse me, in all cases, what you see is a bimodal shape. A bimodal shape with 2 different modes. The first, this mode here corresponds to short duration bursts. This corresponds to long duration bursts. And so what you have is a mixture of two different distributions. All right, so that completes exercise 2. I don't know if I have time for exercise 3 left, but let me squeeze it in if I can, if you don't mind. To do exercise 3, so if you go to exercise 3 in the tutorial sheet, it's about anorexia data set. Anorexia, I guess, is some kind of a disease or something. So you, this is the data set. You have 4 columns of data. So you have case number, you have pre-weight, and you have post-weight, and then the last column is the treatment column. So let's copy this and paste it here, right? Let me call this data anorexia, A-N-O-R-E-X-I-A. All right, read dot table in quotes, quote data equal to true. So if you now type names anorexia, you see we have 4 different columns with 4 different names, right? Okay, now what you need to do is, I think the question here is to see, which treatment has the most effective treatment. There are 3 different levels for the treatment. And the question is to see which of these 3 different treatments is most effective. Now to do that, we're gonna take the difference between the weights before and after the treatment. So this is the post weight, that is after the treatment. And this is the pre-weight, which is before the treatment. So I'm gonna create a variable called DWT, which is, bear with me guys, I may run out of time. Okay, just only by a few minutes, not long. So I'm gonna take the difference between the weights before the treatment and after the treatment. So this is, sorry, I spelled it wrong. Okay, you see what I have done. This is the difference between the weights. Now I'm gonna define 3 different weights depending on which treatment was applied. All right, before that, I need to define treat. Okay, let me define treat to be anorexia treatment. This is the treatment level, right? Now, the next thing I'm gonna do is the standard difference, right? Which the DWT when the treatment is equal to 1, all right? And then the cognitive differences for cognitive treatment when treatment is 2, and then something called, I think it's FAM, I don't know what it stands for, but that's when treatment is equal to 3. Then I will do the summary statistic for each of these. The summary statistics for the standard treatment is, oh, what did I do? Excuse me, I think I must have made a mistake here. Just, DWT. What did I do? Anorexia pros. Excuse me. Excuse me, just a minute. I think I messed up something here. Just give me a sec, guys. Okay. Oh, it should be pre. Yeah, I made a spelling mistake. All right, let's see. I'm not being clever today. Sorry. Okay, this is standard. This is one. And this is one. Okay, then you should do a summary statistic. You should do a summary statistics of standard. Right, this is what you get. This is the summary statistic for cognitive treatment. That's treatment number 2, and this is when treatment number 3 is applied. And from these 3 summary statistics, you can see that which one is most effective, because the one that is most effective is the one that has the largest median, which is treatment number 3, right? Okay. Treatment number 3, which is the most effective. And also it has the largest summary statistics among the 3 treatments. It has the largest median, it has the largest mean, it has the largest quartile, and it has the largest maximum among the three treatments. And you can actually see, you should do a box plot. You should do a box plot of DWT versus treatment using the tilde command. Right? You will see what actually happens. See the difference in the weights, that is the difference in the weight before and after the treatment, is largest when treatment is 3, is second largest when treatment is 2, and is smallest when treatment is 1. So the most effective treatment is treatment 3, right? I'm sorry, I ran out of time. So no, I'm just finishing the tutorial from 4 to 5 right now. So the next tutorial will start at 5 to 6. The time now in the UK is 5 minutes to 5. 5 minutes to 5 right now in the UK. I mean, if you're not in the UK, I don't know what you guys are. So you still have 5 minutes. You still have 5 minutes before the next session starts. But let me ask you guys now, do you have any questions on the session that just finished? Hello, guys. Any questions on the session from 4 to 5? Come on, guys. So I've done the 3 examples, the 3 exercises. I know it took me some time, but I'm sorry for that. Try to do things better next time. But I hope you understood. I hope you understood the 3 exercises and their solutions. Have a good day, guys, and I will talk to you later. And one final request is that if you haven't completed the feedback form, can you please do so as soon as you can, please, right? All right. I'll talk to you soon later. Take care and have a good evening. Hello, guys. Good evening. How are you? All right, guys. Um, Good evening, guys. Sorry for the delay. Um, so today is a tutorial on the based on R. Um, so you should go to the course website. The tutorial sheet for today is this one, right? So this is the R course session. So I will go through as usual. I will go through line by line, and also do the 3 exercises at the very end. All right. All right, guys. So any questions you guys have, feel free to use the chat room, right? So the first thing we need to do is to open R. So you go into your start button and you go down, scroll down, and then you choose R, click on R here and choose 64. So this is the window that you will get, okay? Right, now the first thing is I'm gonna talk about how to use the rep command, REP. The rep stands for REPs, means repetition, repetition. I don't know how to spell it. Excuse me if repeat, that may not be the correct spelling. Correct me if I'm wrong. Anyway, I hope you know what I mean. Okay, so repetition is just, so suppose rep times 2. So that what that means is that it means that you are repeating x twice. So 322, 57, 322, 57. And you should say times 3 is repeats x 3 times. 322, 57, 322, 57, and 322, 57, right? Okay, so you can repeat it as many times as you want. Now you should type something like this. What it will do is, you see, it repeats the first element 1 time, the second element 2 times, the third element 2 times, and the fourth element 3 times. So you get this vector, right? And suppose you type this. Suppose you type this, right? What here, length out means is the number of elements that you want to have in the output vector. So x is repeated enough times so that the total number of elements is equal to 8. So it's 322, 57, 322, 57. Now, if you change this to 9, then it will be 322, 57, 322, 57, and 3. Right? So it's the number of elements that you want output, right? Okay. Now, if you type this, you get the vector 1, 2, and 3. Sorry, a vector containing the element 1, 2, and 3. Now, if you say rep of this times 2, you will get this. It's not saved. Yeah, if you want to save it, Mario, then you need to give it a name, right? You need to give it a name. So, like, suppose you want to save this, right? Suppose you want to save this, you may call it, say, y or something. If you say, then y will contain the numbers 1, 2, 3, 1, 2, 3. So 1, 2, 3 repeated 2 times. So you need to save it. I mean, you need to give a new name in order to save it, right? Now you should type rep 1, 2, 3 each 2. It means that each element is repeated 2 times. 1, 1, 2, 2, 3, 3, right? Now you should say times like this. What it means is that it repeats 1 times, 2 times, and 3 times, right? And you can also apply rep command to letters, not just numbers. You can also apply them to characters like this, for example, right? So here you're repeating A 2 times, B 3 times. So you get the output A, B, B, right? Okay. All right, the next thing I want to talk about is sequence. SEQ stands for sequence. It's a sequence of numbers. right? So suppose you type sequence from 2 to 8 in steps of 2. This is what you will get. You get 2 plus 4 is 2. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8, right? Now, if you type by 3, then you get 2 plus 3 is 5. 5 plus 3 is 8. Now, if you type 3.5, you only get these two numbers because 2 plus 3.5 is 5.5. 5.5 plus 3.5 is 9, which is beyond this range. You see, we are only going from 2 to 8. So anything beyond this range will not be in the output, right? Right, now you can also say a decrease, you can also have a decreasing sequence like this. So you can go from 5 to 2, decreasing by minus half every time. So it will be 5, 4.5, 4, 3.5, and so on, right? And you can also have length out. When I say length out, it means the output vector must have a length of 6. So here you have a vector from 2 to 8, which has 6 elements in it, right? But the numbers in this sequence must all have the same distance. In other words, the distance between any two consecutive numbers must be the same. You see, 2 plus 1.2 is 3.2, 3.2 plus 1.2 is 4.4, and so on. So they are equally spaced, but there must be 6 numbers, right? And similarly, you can say something like this, for example, suppose you have this Z, which is a sequence from 1 to 5. Then you can say sequence 4 to 14 along with Z produce this. It will produce this. And here, once again, you have a sequence from 4 to 14, which is of length 5, and the distance between any two consecutive numbers must be equal. In other words, they are equally spaced. As you can see, it's 1.5 plus 4 is 6.5. 1.5 plus 6.5 is 9, and so on. Okay, so that the first page. The next page is about summary statistics. So let me go to any questions so far, guys. Let me go to the Moses data, right? This is a data set I talked about earlier in the first tutorial. If you have any questions, feel free to use the chat room, okay? All right, so I'm gonna read this data into an object called Moses, right? So I'm gonna use the read table command to read the data with header equal to true, okay? Right, so if you type names Moses, Moses, it gives you the name of the column that you just read. So let me call Moses $time. Let me call this T, right? Okay. T for time. So this is the data that we just read. Now, if you want to summarize this data, you can use the mean command to get the sample mean, this to get the sample median, this to get the variance, and this to get the standard deviation. And there's something called 5 number, which I will explain in a minute. This will produce 5 numbers. The first number is the minimum, the second is the first quartile, the third is the median, the fourth is the third quartile, and the last one is the maximum, right? So if you assign this to something called, say, FNS, right? Then FNS will contain these 5 numbers, right? Remember the IQR, the interquartile range, is the difference between the third quartile and the first quartile, right? So IQR for this data set is 1. Ella Shaw. Yeah, can you repeat how to enter the Moses data set? All right. So what I have done, Ella, is to use this command. Can you see this? Sorry. Use this command read.table, open bracket, and then the URL for the data set, and comma, and then header equal to true. So this command here, right, will read the data set, Moses, right? So if you type Moses now, it will contain 2 columns. The first one is a counter column, which you can ignore. The second is the column that we were looking for, which is time. So Moses $time is the column that we're looking for. And I call this T. So T denotes the data that we just read, okay? Right, now there's another, in addition to the 5-number command, there's something called the summary command you can use. And that produces the following output. That is the minimum, the first quartile, the median, the mean, the third quartile, and the maximum, right? And in addition to this, there's a quantile function you can use. The quantile function takes this form. Now, the type equal to 6 is something that I will use for this course, but there are different types that can be used. But in this course, I will always use type equal to 6. Now, if I use this command, then I get this output. So what you have here is the 0th quantile, which is the minimum, the 25th quantile, which is the first quartile, 50th quantile, which is the median, the 75th quantile, which is the third quartile, and the 100% quantile, which is the maximum, right? Now you can also have type 7, but type 7 it produces slightly different results, and because it uses a different formula from what I taught you in the class. For the formula that I gave you in the class corresponds to type 6. But FNS is, okay, let me show you. FNS is it's not a command, it's just the name of an object for the 5-number summary, right, Sophie? So I just gave, you could have called it anything else, Sophie. So I just called the 5-number summary, which is this one, FNS. It's just a name of an object, right? Okay. So about the contrast once again, I will use, as far as this course is concerned, I will always use type equal to 6, but there are other types, right? Okay. The next thing is page 4 of the tutorial sheet. If you turn to page 4, you will see what I'm doing. There is a command called Windows record equal to true. So when you issue this command, what it does is it records everything that you do afterwards, right? I don't want to do that now, so I will not issue this command. So when you type this, it automatically will record everything you do afterwards, all right? Now, device equal to new, this command here, Alexandra, yeah. It's just a name, Alexandra. I could have called it anything else. I know in the tutorial sheet, they use the name Moses -Q7, but that's just for the sake of name. You know what I'm saying? I could have, it just a name, just a name, Alexandra. It doesn't mean anything. I mean, I call it anything else. So anyway, div.new, what it does is it opens a new window like this. I hope you can see this. So this is a new window, and every window has a number associated with it. So in this case, the number for this window is 2, right? And you can open as many windows as you want. Like you should, now you see we have 2 windows. We have a window with device 2 and a window with device 3, right? You can open as many windows as you wish, right? And if you type device set equal to 3, then it will set device 3 to be active. So at the moment, device with the number 3, which is this one, is made active. So anything that you plot or draw will be on this device, on this window, right? Okay. Now, if you want to remove a window with number 3, then you use the command device.off. So this will, as you can see, let me show you. Now I have removed the window with number 3. And I can also remove this window by changing this to 2. So I have now removed both windows, right? I have now removed both windows, right? So this is just a very simple command, device, you know, how to set, how to open a window, how to close a window. It's a very, very simple thing to do, right? Okay, the next thing is I'm going to show you how to do a bar plot. Now let's create a data set, which is something I talked about last week or the week before. So let me create this data set with the party names of the 5 parties: Conservative, Labor, Liberal Democrats, UKIP, and other. So these are the 5 party names. And I'm going to repeat each of these. So I'm going to repeat Conservative 369 times, Labor 314 times, Liberal Democrats 75, UKIP 118, and others 124. So I just created this data set, right? Okay. Now I'm gonna convert the data into a factor variable using this command, right? So now it's sorry, I misspelled it. Factor, right? Now it's a factor, right? Okay, now you should type table and the name of the factor. It will provide a summary of the data. So you see there are 369 seats for Conservative, Labor 314, Liberal Democrats 75, and so on. Now you should plot this. This is what you will get. All right. So this is the plot. Is a bar plot, right? Bar plot, as I mentioned before, is used to represent categorical data. So here you see it shows you how many seats or how votes each party got, right? Each of the 5 parties got. All right. All right, the next thing I'm going to talk about is histogram. Now, let me go back to the time data. Remember the Moses data I talked about. This is the Moses data, right? Now, if you type hist t, this is what you will get. This is a histogram of the Moses data, right? Now, here, the y-axis is on the frequency scale. Now, if you want it in the density scale, what you need to do is the following. You say frequency equal to f for false. So now the y-axis is on the density scale, right? Okay. And you can also determine how many breaks you want on the x-axis. So for example, if you set breaks equal to 14, you will have 14 breaks on the x-axis. And you can choose the interval for each break by specifying, again, using the breaks command. You should say sequence from, say, 47 to 51 in steps of, say, 0.4. This is what you will get. You see the breaks along the x-axis are from 47 to 51 in steps of 0.4, right? And you can change them as you wish. Like suppose you want it from, say, 46.8 to 50.8 in steps of 0.4, and this is what you will get, right? Okay, so the x-axis can be changed as you wish using the breaks command. Right. The next thing I'm going to talk about is box plot. Now, look at the MOS data one more time. As you do a box plot of t, this is what you get, right? So once again, as I explained before, the middle line is the median. This line here is the first quartile. This is the third quartile. And this is the lower adjacent, and this is the upper adjacent. And the lower fence and the upper fence are beyond the plotted region. They're not within the plotted region, right? Okay. Okay. Any questions so far, guys? Are you okay or not? And feel free to talk to me, guys. Right? Any questions? Are you guys okay so far? Hello? Okay, good. Thank you. I mean, just even if you don't understand a little thing, just, feel free to say that. Right. The next thing I'm going to talk about, I'm going to go back to the website and I'm going to read the following data set here. This is a runner's data set, right? Let me copy this link, right? And go back to R. Okay, so there is a question. Can you explain again the last one with the histogram? The last one with the histogram. All right, you mean this one. Right, when I did the histogram, yeah, what I meant is here I'm doing a density version of the histogram with the breaks. When I say breaks, I mean the intervals for the x-axis are from 46.8 to 50.8 in steps of 0.4. That which means that each interval is of length 0.4, right? And the interval starts from 46.8, which is round about here, and go to 50.8, which is around about here somewhere, right? So the intervals range from this to this, and each interval is of length 0.4. Okay, I hope it explains. Thank you. All right, the next thing, all right. The next thing is this. I'm gonna read the runner's data set. So this is the data set. So I'll use the read table command, right? And I'm gonna call this runners. I mean, you can call it any other name you wish. And header is, as usual, is equal to true, right? Now, if you type runners, this is the data set you have. And the name, if you type names of runners, it has two columns. P-mol is like a concentration, and the second column is group. So you see that there are two levels for the group. One is successful. So some runners were successful, the others were not successful. So they collapsed. They did not complete their distance, right? Okay. Now, if you want to do a box plot, say suppose you want to do a box plot of the concentration level, right, versus this is what you will use. There's a symbol called tilde, which you can find in your in your keyboard, versus group, this is the picture that you will get. You see, there are two different box plot depending on which group that you belong to. So there's this collapsed group, and there's the successful group, and the concentration values for the collapsed are much higher. Excuse me. And the concentration values for the successful group is much smaller. And also the variabilities are very different. The variabilities for the collapsed group are a lot bigger compared to the variability for the successful group, right? All right, so that's the beauty of having to be able to draw a histogram, to be able to draw a box plot. It tells you a lot about how the two different levels, so the groups, differ. All right, you can also pick up, like, you type runners again, right? The concentration takes a variety of different values. Now, suppose you want to pick certain values of the concentration that are greater than 100, right? So let's call this high concentration. So what I'm doing here is I'm picking out the runners with the concentration level greater than 100, right? Now, you can pick out those runners by using the command called subset. So subset of the runners with the subset corresponding to high concentration, right? Now, if you type runners high, this is what you get. So, sorry, I think I made a mistake here. Sorry, this is subset, sorry guys. This is what you get. So these are the subset of the original data set where the concentration value is greater than 100. The dollar sign, yeah, the dollar sign, it just picks up, I mean, I think I mentioned the dollar sign before. The dollar sign picks up like the column that corresponds to the name. So for example, runners $PMOL picks up this column, and runners $group picks up this column, John, right? So it's just a dollar sign is just used to pick up the column that you want, right? So depending on, like, that's why you have the names, right? So if you put runners $PMOL, it will pick up this column. If you put runners $group, it will pick up this column. All right, now, you should do a summary. You should do a summary of this, okay? Right, this is what you get. You see, all of these seven runners have collapsed, and none of them were successful. Right? So for this reason, because none of them were successful, we don't need to have this level. Right? We don't need. There's no need for us to have this level because all of them collapsed. Right? So the one way to do that is to use this drop levels command. So you should say drop. So I'm going to drop the levels that have zero frequency, right? Because we don't need, I mean, anything with zero. We don't want them, right? Okay, now if you type this, you see there are all 7 of them collapsed, right? And none of, I mean, the one with the zero frequency has been dropped. Okay, all right. So that's it. Okay, the next thing is scatter plot. Now suppose x is from, say, 0 to 5. So you have this number 0 to 5. Now if you do plot x versus, say, y, which is x squared, this is what you will get. So what you see is a part of a parabola. I'm sure you've done parabolas in your first years, or maybe in your A level. Now instead of Let's change this to -5 to 5. And let's do the plot one more time. You see this, right? Now this is more like a parabola, right? And you can actually use the command type to join the line, to join the points. By the way, this is L, not 1, okay? So this is what you will get. So let me remind you, this L here stands for line, right? L means line, okay, not 1. Don't confuse with 1. It's L, okay? And you can also use color command, like if you say color equal to, say, 5. See, this is, you have a different color, not just black, but a different color to join the points, right? Okay. And similarly, you can have like in the tutorial sheet, you can define x to be anything else, say from 0 to 5. Sorry, to 5. Length out equal to 100. So what this means is that it picks numbers from 0 to 5 equally spaced of length 100, right? Then you can plot, say color equal to 2. So it will produce this, right? You should do plot x squared versus x, type equal to L, color equal to 2 will produce this curve. And then you can use the lines command. Lines command can be used to plot something on top. So let's say, suppose you want to plot, say, a cubic on top of the quadratic, and this is what you will get, right? So the blue line is a cubic. The red line is a quadratic line. All right. Okay. So the lines can be used to plot something on something that is already plotted, right? Okay. All right. So that's the tutorial. Now we have 3 exercises to do. How do we choose the space between them? I mean, I don't really understand what you mean, Defin. What do you mean by space? I mean, space in the 100 numbers. Yeah, yeah. I mean, all right. In this case, yeah. I mean, you can. It doesn't need to be like this, madam. I mean, it can be anything else. I mean, I just chose it just for random. I mean, I could have chosen the space. All right, the space. All right, the space between numbers has to be equal. So if you say length out equal to 100, you should say length out is 100. Then there are 100 numbers between 0 and 5, and the distance between any 2 consecutive numbers must be equal. Is that what you're asking for? I mean, they must be equally spaced. They must be equally spaced between 0 and 5, but there must be 100 numbers, right? Okay, right. All right, now there are 3 exercises at the very end of the tutorial sheet. So I'm going to do the first exercise. So let me start with exercise 1, which is about the simulated data. So let's go to the course website. Which what am I doing? Course website. This is a course website. Now the first data set is this data set. So I'm going to copy this. I'm going to paste it here. Now I'm going to read this data. Let me call this simdat, or simulated data, and read dot table header equal to true. How to save work in R? Yeah, to save work in R, you go into File, madam. You go into File, and then you choose Save Workspace, right? Go into the File menu, and then you choose Save History or Save Workspace. Either one of them will do it for you, right? That's how you do. All right. Okay. All right. Now the SIMDAT has been read. Now, if you want to check the names of the columns, you just type names SIMDAT. It says there are 2 columns, right? You can actually see the 2 columns by typing this, right? You see there's a case column and there's the simulated data column. And we are interested in the simulated data column. So let's call this XS, right? And you can call it anything else. Now, if you type the file number summary, the file number summary of XS is, let's call this FNS. So FNS is this. These are the file numbers. So remember, the first is the minimum, the first quartile, the median, third quartile, and the maximum. Now, if you want to find the IQR, the interquartile range, IQR is the difference between the third quartile, which is this one, and the first quartile, which is this one. So IQR for this data set is 2.64777. You can also use the summary command to summarize the data, right? And this is what you will get. So here, this is the minimum, the first quartile, the median, the mean, third quartile, and the maximum. And you can use the var command to compute the variance. You can use the st command to compute the standard deviation. And you can use the box plot command to look at the distribution of the data. So you see, this is what you see. And you see that the distribution is not exactly symmetric, because for a distribution to be symmetric, the median has to be halfway between the first and the third quartile, but which is not. It's kind of slightly skewed, right? Because it's not halfway, right? And you can also do a histogram. Sometimes histogram can be more informative than the box plot. Excuse me, HIST. Right, this is the histogram. Once again, it shows that the distribution is not exactly symmetric, right? You can change the frequency to the density column by saying frequency equal to false. So now you see that it produces the density on the y-axis, and you can change the x-axis as you want by using the breaks command. So you should say breaks equals, say, sequence from say 6 to 16.5 to in steps of 1.5. This is what you will get. You see, so the breaks on the x-axis are from 6 to 16.5, and the length of each bar is 1.5, right? And you can choose any other numbers you want. Like if you want it to be, say, from 6.25 to 15.25 in steps of 1, this is what you will get, right? Now there's another question. What is the difference between FNS and summary? All right, the FNS, the summary contains more information than FNS. Remember, the FNS only contains the minimum, the first quartile, the median, the third quartile, and the maximum, whereas the summary contains the minimum, first quartile, median, mean. So it contains one more number, which is not, the FNS does not contain the value for mean, right? Okay, whereas the summary command does give you the value for the mean, as well as the 5 numbers of the FNS. All right, so that's the answer to your question, man. You should follow what I'm saying. I hope you do. Okay. All right. So this is, I was talking about the histogram. So you can use the breaks command to determine the the x-axis, the range of the x-axis, and the length of each bar, right? Right, so that completes exercise 1. Any questions on exercise 1 before I do the next one? Hello guys, talk to me. You've been keep quiet today. Are you okay with exercise 1? Guys, thank you. All right, let's go to exercise 2 now on the tutorial sheet. Exercise 2 is about geysers. I don't know whether you've been to the Yellowstone National Park in the United States, right? It has 222 eruptions, and some of them are long ones, some of them are short ones. All right, so the data that we have, is this one here. This is the Giza Data Set. So I'm going to copy this. As you can see, there are 3 columns. The first one is the day. The second column is the duration of the eruption. And the third column is the interval. And the one we are interested is in the second column. So I'm going to call this data Giza. Okay. Open quotes and quotes, and header equal to true as usual. Now if you type names of the data set, it will show you the names of the columns, the day, duration, and the interval. All right, the column that we are interested in is the second column. So I'm going to pick up Giza dollar duration. It will pick up the second column. And let me call this XD, right? You can call it any other name, right? So this is the column that we are interested in. All right, so let's do a summary statistic. The summary of this data set is this. So you can see the smallest duration is 1.7, the largest duration is 5.2, the median is 4, and so on. The variability of the durations is this. The standard deviation of the duration is this. Now, if you do a box plot of XD, it looks something like this. As you can see immediately, that this distribution is not symmetric, it's highly skewed, as you can see, right? All right, now in this case, it's useful to do a histogram also. So let's do a histogram of the data. So histogram of XD will produce something like this, right? So here I'm using the frequency scale. Now, if you want, you can use the density scale. So with frequency equal to false, let's say breaks equal to 16. And this is what you will get. Now, what you see here is interesting because you see a bimodal shape for the density, right? There are 2 modes. There's a mode around here, and then there's a mode around here. And what it means is that there are geysers that have short durations, and there are eruptions that have long durations. And this distribution is a mixture of 2 different distributions. One distribution for short duration eruptions, and one distribution for long duration eruptions. So this is nowhere being symmetric, but it's a mixture of 2 different distributions, right? Okay. Now you can change the breaks as you wish. Like say, suppose, say you want, say, from 1.5 to say 5.5 in, sorry, what am I typing? To 5.5 in steps of say 0.25. And you will get a plot look. What did I do? BRE breaks, C should be sequence, sorry, sequence, SEQ. This is what you will get. So here the breaks are defined from 1.5 to 5.5 in steps of 0. So each bar is of length 0.25, right? And you can change this to anything you want, like 0.5 to get this. You can change this to say 0.75 to get this. And you can change this to 1, say, to get this. But in each case, what you see is a bimodal shape. Whatever in each case, what you see is that the density of the duration data is bimodal with two different modes, right? Each the smaller mode corresponds to short duration eruptions, and the larger mode corresponds to long duration eruptions, right? So this completes exercise 2. Any questions on this, guys? Any questions on exercise 2? Thank you. Right. Are you sure? Don't be shy to ask questions. Okay. Exercise 3. The last one is exercise 3. It's on anorexia data set. I'm not a doctor, but anorexia, I believe, is kind of a disease or something, right? So I will copy this data, right? There are 4 columns to this data, and the first is the case. The second column is the pre-weight. The third column is the post-weight, and the final column is the treatment column, right? Okay, so let me read the data. I'm running out of time, and I won't take too much time to finish, so just bear with me, guys. Excuse me for running out of time. Excuse me. So let me call this anorexia. Is it the correct spelling? Anorexia, yeah. So now you should look at the names of names of this data. There are 4 columns for this data set, right? The first column is case, the second and the third and the fourth columns are the ones we are interested in. So the second column is the weight before the treatment. The third column is the weight after the treatment. And the final column is the treatment number. Now, the question here is to determine which of the treatments is most effective and why, right? That's the question here. So what you need to do is the following. Okay, let me, for short, instead of calling it treatment, which is a long word, right? Let me call it treat, all right? Let me call it treat for short, right? And let DWT represent the difference in the weight before and after the treatment, right? So this is the post weight, that is after the treatment, and this is the pre-weight, pre-weight, that means before the treatment. So this is a very crucial variable, DWT, right? Now, DWT, there are 3, you should look at treat. Treat has 3 different treatment levels, 3 different treatments, 1, 2, or 3, right? Okay, now I'm gonna take the differences corresponding to each of the 3 different levels, right? So let me call, standard. Let me call this when treatment is 1, right? And let this denote when treatment is 2, and let this denote the differences when treatment is 3. All right, so you see I have defined 3 different objects. The first object is this one, is the differences in the weights when the treatment is 1. And these are the differences in weight when the treatment is 2. And these are the differences in weight when the treatment is 3, right? Okay, now I'm going to compare the summary statistics. So summary of the differences in weight when treatment is 1 is this one, right? When treatment is 2, you get this. When treatment is 3, you get this. Now, looking at the summary statistics, you see that the weight has changed a lot when the treatment is 3, right? You see, if you look at the median, the mean, the third quartile, and the maximum, these are the largest values of the 3 treatments that we considered. These are the largest values. This is the largest median that we have. This is the largest mean we have. This is the largest third quartile we have. And this is the largest maximum that we have. Therefore, treatment 3 is the most effective of the 3 treatments because that has increased the weight before and after the treatment most dramatically, right? In fact, you can see this if you do a box plot. If you do a box plot of DWT, that is, DWT represents the, DWT versus treatment, that can be easily seen. You can see this easily, that you see very clearly that treatment 3 has made the largest differences in the weight, which is this one, right? And treatment 2 has made the second largest differences in the weight before and after the treatment, whereas treatment 1 has made the smallest differences in weight before and after the treatment, all right? So the most effective treatment of 3 is treatment 3. The second most effective is treatment 2, and the least effective treatment is treatment 1, right? Okay, guys, so this completes exercise 3 and also completes the tutorial sheet. You have any questions, guys, please? Hello, guys, talk to me. Are you still around? Hello, guys. Any questions on the tutorial that we just finished? Please feel free. Okay, thank you, guys. So have a great evening. I will post the video for this solution online within the next hour. In the next hour, you will see the video on the YouTube channel and also on the UOM channel. I mean, if you're in China or some other country, you may not be able to see YouTube. All right, so see the UOM channel instead. All right, and one final reminder: if you haven't completed the survey, the week 2 survey, could you please do that as soon as you can? Thank you very much. I would be most grateful if you could complete it. Thank you. Have a great evening, guys. And any questions you guys have, you can contact me 24/7 as usual, by phone, by email, by Skype, or